Hello friends, welcome back. So in the last video, we have already seen how to create a simple to-do list application project with the help of Jetpack Compose. But in that, we were using all the CRUD operations, but the data was not persistent. We were just adding and removing the items and editing the items at the runtime from the list. If we exit the application, all the data was lost. But we are now taking that project itself to the next level. We'll be adding a persistent layer of the room library in that project so that all the contents will be saved to our local storage. Even if we exit that, then also we'll the next time we'll open, we'll see all data as it is. Again, we'll be adding an MVVM structure to this project, and again we'll be using a flows for this one as a state flows to make the state updates automatically. So all of these things we are going to learn in this application, in this project, in this tutorial, and it will be of all the production grade, so that you can actually deploy the application and that type of project we are going to build. So make sure you stay till the end to get the full idea about this project. So for now, let's get started. Okay, we are now in the Android Studio project, and let's see what we are going to build. So this is the to-do list application which we have already built in the last video, but this is not the same. In this we have already added a persistent layer. So if I created a new item, it will look pretty the same like the last project, but it will now have a persistent storage. Item 2. Okay, now I have checked this item. I am going to edit this item as an item 3. I'll update. Okay, now we can see all the modifications here, and now exit tab. I'll also kill that from the recent tabs. Okay, and now I'll open the app again, and I still see all of the data is persistent because this data is being saved in a local SQLite database with the help of room library. So that's what we are going to learn in this tutorial. So yeah, if you have not gone through the previous tutorial, then please go through this tutorial and then come to this, because it will make you a better understanding. And if you want, you can skip that and you can just clone the GitHub repository directly into your project and continue with this project. The link is in the description for the GitHub and the video also. So yeah, now we want to add a few dependencies for this one, which I have already added. So in the project level, build.gradle.ktx. So this is now in the transition phase of the KSP from the Kotlin. So KTX, from the KTX to KSP. So this is the transition process. That's why we have to add these few things. If you are using the same version from mine, so you must also add these dependencies. This is the dependency for the dev tools of the KSP. In the app level build.gradle, we need to add this ID as well, devtool.ksp in the plugins, and then these are all the integrated main dependencies here. This is the room library version. These two are the dependencies for the room runtime and room-ktx, and this is the one we require for the lifecycle runtime, so that we should be able to convert the state which is coming from the view model to the compose state. We that is, we can convert a state flow into a compose flow. That's what this dependency will allow us to do with the help of its one inbuilt function, collect with lifecycle. So that will be seen in the next while we will implement it. And this is again a dependency for the KSP. It will also use the same version. So you can find all these things which we need to be added in the description box itself, or if you directly clone the project, you will get directly this. And in the Gradle.properties, now new versions of the Gradle are coming with the built-in Kotlin. So we don't need to we don't need to refer explicitly different Kotlin versions. But currently this is not that much stable, so that's why Google is also recommending to add this flag if you are getting errors while building the project. So that's why I have added this flag as well. If you are also getting some type of error related to the Kotlin version, then you in the error also this flag is given that you can set this one disable allow Kotlin source set, so that it will disable and use the default behavior for now. Until it is gonna stable, we are free to use this one. So yeah, these are the Gradle related changes, and now we'll start with our actual implementation. So for the room library, if you don't have any idea about the room library, then I also have a dedicated video about the room library. Then you can go watch that video and then come back to this later. So in this, while implementing room library or offline storage in our application, we need a table, and in the room we call that table as an entity. So that is generally a data class which we use for any type of operation. So we have this todo item data class, and we want to use it as a table. So in the table we reference it as an entity. So we use annotations in the room. So I'll annotate this with an entity, and for the primary key I'll set this primary key, set this id to primary key, and with the id as an auto generate equal to true. So if it is auto generating, then we can set it directly as a null. Okay, yeah, now we have a table setup. The next thing we need is a data access object, DAO. So we need to create that. So just right click on new, before yeah, new Kotlin class file, and then we'll write to do DAO. So it will contain all of the queries which we need to get and return, I mean, do anything with the database. So we'll get one function here, function get to do items list, and this class, sorry, this will be not an class, this will be an interface, and we will also annotate this with an DAO. These all annotations are coming from androidx.room. So and also we don't need to provide any implementation for all of any of this function. Room library will automatically generate the boilerplate code for us. So this get to do list items function, this what we expect this function to give us all of the to do list item which we have in the database in the table. So it will have a written type of list of to do item, to do item. Okay, but as I have already told, we will be using a flows to make the UI state automatically, to make UI updates automatically. So we will be using flow here itself, so that we'll get output itself in the flow. Make sure you take from this content.coroutine.flow. So now we'll have a stream of all the updates. So and as we are getting the flow, the updations will happen automatically. We will see the magic of this one at the time of implementation. So I'll annotate this with a query, and I'll apply a select query here, select star from to do item. Okay, that's it. This function will give us all of the required items, and then I need one for the insert, and again I'll need one for the update. So we have, for the insert and update, we have different we can have different functions and can have different annotations, like just like @query, @insert annotation. But instead of doing that, we have one operation, one annotation which can help us to combine both of these, insert plus update, that is a upsert. So we'll be using that itself, upsert to do item, and we'll take a to do item here as a parameter @upsert. Yeah, this is the one which will help us to, if the item already exists, then it will automatically update it. If the item is new, then it will insert it. Update plus insert equal to upsert. That's how the room designed it, and it's a very good thing to use it. Then we have read operation, insert, and update. So we need only a delete operation now. So I'll write one function for the delete to do item. So to do item, okay, and I'll now annotate this with a delete. Okay, that's it. We don't need to write any queries, and that's it about our interface, about our data access object. Now the next thing we need for the persistent storage is, before that I'll I have already told that we'll be structuring this with the in the MVVM pattern. So I'll create a new package here as a model, and as these are the model things, I'll move both of these classes to the model. Okay, in the model now we have this is a UI, and we'll create another one when we'll create a view model. So the next thing we need for the model is a repository. Repository is actually we can directly interact with this data access object class interface, but we are not going to do that because we want to build an application with a production grade standard. That's why having a repository is always a recommended approach. So I'll create a new repository here. I'll name it as a to-do repository, and this will have now a parameter as a DAO, private val to do DAO. Okay, and I'll have a function. I'll have a same function which the function I have here. So I'll, instead of getting a function for this one, I'll just create one parameter here, val to do items to do items list equal to do tao dot get to do items list. Okay, one thing we missed, we need this both of these two function and the suspend one, because the operations will happen on a background there. That's why we need these both of the function as a suspend one, but we don't need this function as a suspend because we are receiving directly a flow, and flow will be able to handle it directly. We'll be directly getting a stream of changes at the same instance, so that's why we don't need a suspend call for that. Okay, now we have these to do list items. Next one is again function get, not get, observed to do item, and we'll receive a to do item here, and here we can again call a to do tau dot observe to do item and pass this to do item which we have received. Sorry, to do item. Okay, we also make this one a suspend one, again a suspend function delete to do item. Let's receive to do item here, again call to do dao dot delete to do item and pass this to do item, delete it. Yeah, now you have this repository complete. But now you will think we have we are doing the same function, same thing in a to do dao data access object, and we are doing the same in the repository. Why we need this repository class? Yeah, the question is right, but as we are building this as in a production level, a production standard, that's why in the production we generally use this repository, and we the classes that can should not directly talk with this DAO, because the repository is the main uh, main element of the model layer, and model only knows where the data comes. So repository will know where the data is stored. If we have data some API call as well, we are getting some type of data from a network layer, from a remote database or API, then also we can write that function itself, and then we can initialize a retrofit instance here, and then we can call that function from here itself. So anyone that is a view model, if view model needs any type of data, then if we had different instances of the to do DAO, if the repository was not present, then view model has to decide if this call will come from an offline database or from a network, and then accordingly they need to create an instance of the specific class, and then make a call. But here view model don't need to don't have any need to remember any of these things. That's why this repository class exists. Your model will directly ask the repository, hey repo, please give me this type of data. I don't know if it comes from an online database or an offline database. Just give me a data. And repository will say, okay, I'll give you your data. And then repository will know about if the data comes from a offline database or an online database. So view model will always ask the repository, or as we are And the repository will decide where the data will come, from where the data will come, and it will act accordingly. So there is a very clear separation of concerns here. Another thing is that now we are getting this from an offline database. If we are now again upgrading this application to the online application, then we don't need this to do DAO. Instead, we'll need a retrofit library instance here, and then we'll make a call to the API, to the remote database. But for that, if the repository was absent, then we also had to make a changes in the view model as well, because for the instance, all of the instances will be present in the view model if the repository was not present. Now, as the repository is present, then view model will just need a reference for the repository, and repository, if we want to make this application to get data from the online, then we only need to make changes in the repository and not in the view model. We don't need to touch a view model layer. We only need to touch a model layer, because model is where the data model is the one layer which knows where the data is stored, and will be directly just if we have changed the data source from offline to online, then it also makes sense to we just need to work on the model layer and not a view model layer. So that is a standard production grade application. Thanks for listening to my explanation, but it was important. After this thing, we have this repository, and now I'll create a database class to do database. Okay, and this will be an abstract class, because we are not going to provide all the implementation of this. Again, we'll delegate it to the room library. I'll annotate this with a database, and we need to specify entities here. Entities mean the classes. So we have this only one entity, that is to do item. So I'll just write to do item double colon class, and it needs a version. So I'll pass a 1 for this, for as it is a first version. This is the abstract class, and then this will inherit from a room database, and we'll have a abstract variable, abstract file to do DAO, to do DAO. We'll have this, and we'll also specify it as an abstract. Implementation will be automatically provided by the room library. Okay, yes, that's it. Now our model layer is almost complete. Now we need an instance for whenever we'll initialize initialize all these things, initialize application, then all these instances should also be initialized. So for the repository instance should be initialized, and repository and this database instance should be initialized, and the best place would be to initialize them at the start of application. Is not in a main activity, it will be an application class. So I'll just create a new class which will extend from a application class. As a to-do app, it will extend from a application class, because the application class is the first one which will get initialized. In that, we'll make a first instance of a database, file database, and we'll make it instance as a lazy room dot database builder. So it needs a few parameters. So it's a context, class, and a name. So context, we can pass it as this. Class is a to do database so clone class.java, and then a name for the database. We can read todos.db. This extension is an optional. You can pass it or don't pass it. That's your choice. And then dot build. This will build us a database object, room database. If I hover on this one, you can see it is a instance of the to-do database. We clear the imports, and then I also need to initialize instance of the repository by lazy again. So I'll initialize this to-do repository here and it needs a DAO as an parameter. So I can get it from a database dot todo DAO. I can get this from the database here dot todo DAO. Okay, so that's now complete. So as we have created an application class, we also need to mention it in the manifest in the application with as a name called todo app. Okay, otherwise our app will crash. Okay, now we have our application class is ready. Now let's move towards view model. So I'll just create a new package called as a view model. Right click on this one, the new class file to do view model. Okay, and here I just need a to do view model, and it will need a parameter of a repository, private file repository. There's a to do repository, and this will be extended from a view model. Okay, now we again what this view model need, we need what the main activity will do. Main activity will get put a request to the view model and then keep observing for the data changes. And so that's how we need to design a view model now. So to do items list, we have this variable, so and it will be a flow, so that will be observed from the main activity. So we'll use the repository dot to do items list. But now we need to convert this incoming flow to the compose flow. That is this will be observed from the main activity. So that's why we need to use a state in for this one. So state in, we need to pass a three parameters here: scope, started, and initial value. So for the scope, we can just pass a view model scope because we are in a view model. The another one is the started equal to, okay, we need a comma here, started equal to sharing started dot while subscribed 5000. And then what third it needs, that is the initial value. So there is what is an initial value of this list? It will be an empty list, so we can just part the empty list here. Okay, now let me explain what all of this is. So this state in will, what it will do, if we hover on this one, then it is a flow of list of to do item. But if we want the UI layer to compose, to observe it and make the changes accordingly, then we need to make it as a compose state. So and compose state can easily observe this state flow, and that's how, as in the output you can see, we are getting a state flow. So UI layer can directly use this state flow and can collect it and observe the UI accordingly. That's why we have applied this state here. So if for the scope, we have this view model scope, and for this started is whenever it started, sharing started, and file subscribed, stop timeout means you can see if we are out of the UI, then it will stop it emitting the values automatically after 5 seconds, 5000 milliseconds. So that's the advantage of this one, and the initial value is an empty list. So the another function we need is a observe to do item. We'll again take a to do item here, but we won't make this a suspend function a suspend. Instead we have this ViewModelScope dot launch. So this will allow, so this is a coroutine scope which will allow us to load suspend functions here easily. So we can just call a to do item, sorry not repository dot upset to do item and pass this to do item. So we are not directly talking to the data access object here. We are communicating with the repository, and repository we don't have in the as a view model. We don't have any idea from where the data is coming. So repository will take care of that. Even if the change happens, even if the data source changes, then we'll have to make the changes in the repository, not in the view model. So ideally we'll be only touching to the model layer and not a view model layer as a data change. That is a perfect approach. And then one delete to do item. Again, we'll have a parameter to do item. We'll again launch a view model scope. It's a coroutine scope. Repository dot delete to do item and pass this to do item. Okay. Now we have everything in our view model. Now, if we didn't had any parameter in the view model, then we can directly initialize it from the main activity. But as we have a parameter in our to do view model, then we need to provide a factory implementation for that in order to uh, give an idea to the UI layer how to initialize this view model. So we'll need a factory. Right click on a new class, it will be a class to do view model factory. And yes, now this will extend from a view model provider dot factory. This will have a parameter as a private val. This will again have a repository as a input parameter that will be passing while initializing the factory. So we are going to override one function of a create here. So in the return, we'll check if model class dot is assigned from, if the model class we are getting here is assigned from a view model, our own view model which we are expecting, that is a to do view model, then only we will be doing this assignment. That is the return in instance of a java clone class dot java is needed. Then we'll be we'll return a instance of a to do view model, and we'll pass this repository as a parameter inside this one, and we'll cast it as a t. Okay. Now if this is not the case, then if we had any another view model, then we might have created a chain of if else or use the when block. But as we don't have, then this is just something weird case, and we can throw an exception here. The illegal argument exception, that argument is different, that is a, we can write a message as a unknown view model class. If we don't have this if the request is not coming from a to do view model, then which one is the view model? This one, as we don't have any expecting another view model in the project, so we can just write unknown view model class and throw an error here. So yeah, that's about the factory, and then we can close this factory. Now it's time to go to our UI layer and make the changes. So the changes will be very minimum. You will be surprised that you don't need to make any major changes here. In the main activity, we are here. The UI layer, finally we need to just initialize a view model. Before initialize, okay, let's initialize it. Well, view model equal to view model provider dot create. So this create needs two parameters, owner and a factory. So owner equal to, we can pass this as a owner, and then for the factory we can initialize this to do view model factory. Yeah, but this needs a repository instance, and now we don't have repository instance in the UI layer. How we can get that? That's where the application class comes in. Here in the application class we have ready-made instances of all of these things, and then going back to our main activity, we can get a reference of that application class. That is a val for the application. We can just write a equal to, and there is a method get application, so we are using a property accessor for that application, and type cut is as a to do app, because we know 100% that this is the application, this is inherited from the application class, so we can uh, type cut this without any worries. And now we can access it and dot repository. It got what is the parameter it wants from the application class. So as soon as the application class is called, instance will be created, and here as we are accessing this instance, this will be created and passed to the ViewModelFactory, and ViewModelFactory is gonna create this ViewModel instance here by returning it. And now if we hover on this one, then we can see that we get a ViewModel as a ViewModel provider currently. But here we also need to mention which ViewModel class we need to initialize. That is a Todo ViewModel class.java. Now if we hover on this one, then we get a Todo ViewModel instance here. Okay, that's how we initialize ViewModel if we have a factory. Then we have this to do item list, which we are doing all the CRUD operation in this list, but now we don't need to create a runtime. I'll just rub it everything and get an instance of this one directly from this view model dot to do items list. But if we hover on this one, then you can see it is a state flow. So you are seeing a lot of errors here because this is a state flow and we need to collect it. So after only connection, then we'll get a list of get this a list instances. So dot collect, at this flow we can collect any type of flow. We have the several collect options here, but instead of normally collecting it, we'll be using collected state with lifecycle. So what this will do, this will automatically, this you can see a description here, collect values from the state flow and replace it as a latest value while state in a lifecycle aware manner. So this is an important lifecycle aware manner. So this you can see that collect a state with lifecycle. So as per the life cycle, if it is on a hold, then it will stop collecting. If the application is in background, then this collection will be automatically stopped, and the view model will, as we have used state in here, view model will also stop emitting. So we will be saving the resources and there will be no chance of the memory leak. So that's why this is the most recommended way. And if you hover on this one, then you can now see this is a this is the state of list of to-do item. But still we can see the error here because this is again a state and not a complete list. To convert that into direct a list, we can use a delegate. Just write a by here, and then we can see this is now a normal list of to-do item, and you can see most of the error has been gone. So now let's resolve this error one by one. On check change, we have this function. After clicking on the checkbox, we don't need to do anything, any of this one. We can just call a method of view model, that is a upsert, and we can pass this is updated item. That's it. No any more struggling with all the state management and getting the indexes. Again here we have this on add click. What will happen after the addition? So we don't need to add in the list here. We can just use the function of the view model dot upsert to do item, and yeah, we are passing this to do item, and we can also eliminate this id as we are delegating this task to the repository, to the room library of the creation of the to do item. As we have set it up as a primary key, you can see here we have set a primary key auto generate equal to true, so that id will be automatically generated as a random by the room library. And then this is the one on edit click. What will happen after the editing? So we again need to call an upsert. We don't need any of this line, we just need a view model dot upsert to do item and pass this newly created to do item here. That's it. And here on delete click, again we don't need all of this. We only need view model dot delete to do item, and we can pass this new. This is the to do item which needs to be deleted. It will be automatically deleted, and as we, yeah, all the rest have been gone, and as we are collecting uh, as a flow, then the modification will be automatically happen. So yeah, our application is now ready. So this is the model layer, this is the view model layer, and we can also create a one folder as a UI, and we can put a main activity here. So that will be, so we will see a view, a model, and a view model, all of these folders here. This is how you can achieve separation of concern and structure your project in a production standard. Now let's run the application and see how it's working. Yes, now our application has been running. I can just click on this button to add a new item, add to do, not a to do, item 1. I can click on add and you can see item 1 has been appeared. I can add item 2 here, add. I can add item 3 here, click on add, it will be automatically added. So we can go on to unlimited number of items. I can edit this item 2 to item 4. We can update and it will be okay. It hasn't updated. Oh, sorry. 2 to item 4. Okay. There is some problem in the update logic. Let's see what is happening here. After the update, we are calling the observe to do item on edit clicked. Let's check on edit clicked. We are passing a new item here. Okay. The to do item, observe to do item, to dollar observe to do item, and we are here using an observed annotation. Yeah, everything looks good. What is now creating a problem? Oh, sorry, I think we have messed up with this edit on click logic. Let me revert this one. And yeah, we were passing the same to do item. That's why it was not the changes we are not repeating. We need to rub these two lines, and of course we need this line because we are using a copy of this and updating a title here. So that's why we can now write view model dot observe to item and then use a updated item. Yeah, now it will work. Let me relaunch, and yes, now application is running and I can edit this item 3 to item 4, and yes, it's reflecting. I can replace, I can edit item 2 to item 5. Yes, it's happening. I can check it. I can also delete any item. Before that, let me close the application, remove it from recent tabs, and then open again. And yes, the data is getting stored. I mean, our persistent is successful. Now I can delete any item. If I deleted this item, yes, we can delete it and that will be preserved as well. Let me close the app and open it again. Item 4 and 5 should be there, and yes, they are there. So this is how we implement to-do list application with the help of Kotlin flows, MVVM patterns, and the room library in the Jetpack Compose. So that's how we do all this project and with the production level standard. I hope now it's clear to you. If you still have some doubts, you can put your comment in the comment box below. I will try my best to answer all of your queries. Alternatively, you can also join a WhatsApp group of AshishMobileDev where similar like-minded developers are there to help each other and grow together. And you can also get a chance to get a guidance directly from me on that group as well. If you are a complete beginner about Android development and want to learn app development, then you can check out my course about full Android development along with the Kotlin, and it will help you to become Android app developer in just time span of 30 days. And you will also get a customized exercises which are being reviewed and the solutions for that as well. If you like this video, then please click on like, share with your friends, and don't forget to subscribe to the channel so that you will be stay updated whenever a new video is published. We'll meet in the next tutorial with some another interesting topic. Till then, goodbye.